Good morning, Sabrina. So your question was, you can factor by grouping, but you just want a little more explanation on why it works. So let me start with when it doesn't work, which is like most of the time. I did this one out, so I just did these three factors because they seemed easy, and I foiled all that out, and I get this, which is kind of our four-term problem that we were looking at in this section. If I went to try to group this, it totally wouldn't work at all. And it does factor. It factors to something quite simple. But factoring by grouping fails here because I don't have something in common between these two pairs of terms. Here, if I took out an x squared, I'd have an x plus 6. That doesn't even have a common factor. So most of the time, factoring by grouping fails is something I should probably start off with there. What we need it to do for it to work is to take this form right here, where I have some common factor. Here I wrote it as x, but I could also write it as, it could be x plus y plus b x plus y. But the important thing is if I can write it with two multiplications with a common factor in there, which again doesn't happen most of the time, but when it does, then you can factor by grouping. And where that happens is places where you have something like, if I had x plus 5 and I had an x plus 1, x minus 1, a difference of squares there. When I FOIL that out, that's going to have two terms. And so when it has the two-term problem like that, that's where the grouping is going to work when you're going in reverse. So in terms of grouping, I'll just do this out and kind of show what I was saying over here. Here, like I said, when I try to group them, nothing comes out common, so it's not one that groups. But here, when I try to group them, I get y squared. I can pull out a y squared on those two, y plus 3. So if I happen to get another y plus 3, which again, most of the time isn't going to happen, but sometimes it does, and in that case, there's this pretty easy method to get it finished off. So here, if I took out a negative 16, and that's going to leave me another y plus 3. So now I have something of the form where I have something times something plus or minus something times the same something, and that's the important piece, is this is acting like that x I have right there. That allows me to take that out front, and then leaves me my difference of squares. And that's what I was saying, is if you have something where you're going to get a two-term piece out, and you'll often see that this will factor a little further. And by often, I mean in pre-calculus classes and intermediate algebra where they're teaching factoring and this sort of thing. Again, this only applies to a very small segment of problems, but it is one method of factoring. And what you have to do if you didn't know this, at least back in the days before graphing utilities and computers, was terrible. You end up having to do all of this division with, for this one, you would have to divide 1, 2, 3, 4, well, all the factors of 48, essentially, which there's a bunch of them, and the positive and negative ones until you hit one that worked. So it's a super awful guess and check thing back in the day. So having any shortcut was helpful. But that said, again, factoring by grouping only applies to a very small number of problems. And when it does, it's handy. So that's kind of the takeaway from it. Let me know if you had more questions on that or if that got it done.